Welcome to Review Worksheet 2, page 2. So continuing on, now we're on number 6. The first thing it wants us to be able to do is to evaluate the function when x is 4. So in this case, I'm going to go to my graph to where x is 4, which is 1, 2, 3, 4. The y value on that, I'm actually going to go up 5. So the value of the function when x is 4 is 5. Same with the second one. So we want to find the value of the function when x is negative 7. So when x is negative 7, I'm going to go over 7, and in this case I go down 3. So the value of my function when x is negative 7 is negative 3. Now the next thing it wants us to find is where is my function less than 0. So where are the y values of my function less than 0? Because remember, f of x is the same thing as y. So if we start on the left part of our graph, if this point right here has a y value of negative 3, so that has a y value that's less than 0. So if I'm going across, all of these are going to have y values that are less than 0 until this point right here, because that's when I actually have a y value of 0, and beyond that everything is greater than 0. So when we're talking about where am I going to get y values that are less than 0, that's actually going to be an interval. So from, notice, negative 8 right there, and I can include that because I have an ordered pair there. So from when x is negative 8 until when x is 0, which is right there, I'm going to have ordered pairs that have y values that are less than 0. And I can't include 0 because that actually has a y value that is equal to 0. And we want strictly less than. So if it asks where is the value of the function when x that is less than 0, we're going to get from when x is negative 8 until 0. So now when it asks us for what x values if f of x is equal to 0, so this is on my graph, I'm going to go to where x is 0, or where y is 0, and in this case x is also 0, because that's the origin. So for what x values is y equal to 0? Well, that's just when x is 0. And if you want, guys, you can write it as x equals 0, but the question lets me know what you're actually answering. So x equals 0 or just 0, both of those are perfectly fine. So next one, for what x value or values is f of x equal to 1? So in this case, I'm going to go to where y equals 1. Let's get some of this out of there. So when y is 1, that's when I'm going to go up 1. And I actually have a point right there. And right there, that's the ordered pair 1, 1. So when y is 1, x is 1 also. So that's all it wants us to find for that one. And it doesn't cross anywhere else, so that's the only ordered pair when y is 1. So now we want to be able to determine symmetry of this. So we want to say, okay, well, the different types of symmetry that we can have are y-axis, origin, or neither. So in this case, if we want to check, if we want to go y-axis, that's when we would flip the left side of the graph over the right side. And in this case, since they don't line up, this does not have y-axis symmetry. Now, when I check origin symmetry, that's when I actually rotate it around the origin 180 degrees. So if I were to place my point here and rotate this upside down, notice it actually falls on itself. It looks like the same function. So in this case, what symmetry does this graph have? This actually has origin symmetry. Now, if f of x is it even, odd, or neither, this depends on the kind of symmetry. If it was even, if you remember, that has y-axis symmetry. Odd has origin symmetry. So in this case, this graph is odd because it has symmetry around the origin. Now, what is the local maximum as an ordered pair? So I want to say, where does my graph go from increasing to decreasing? So in this case, this is increasing. I go from increasing to decreasing at this point right there. And that has an ordered pair of 4, 5. So I have a maximum at 4, 5. Now similarly, where is the local minimum as an ordered pair? That's where it goes from decreasing to increasing. If I notice over here, I go from decreasing to increasing. So the ordered pair of that point right there is -4, -5. So I have a local minimum at -4, -5. Now the last thing I can be able to do on this is find domain and range. So domain, remember, this is the leftmost part of our graph all the way to the rightmost part of our graph. And this is talking domain, remember, is x values. That's why we're talking about horizontally which way we're moving. So in this case, my graph starts at this point right there, which is when x is -7. And I can have a bracket because that last point is included. And then I have all these ordered pairs until this point right here. That's when my graph stops and I don't have anything past it. So at this point right here, when x is 7, all x values between -7 and 7 have an ordered pair on this graph. So range then is going to go from bottom to top, or the lowest y value to the highest y value, because range again is y. So on my graph, the lowest part of my graph is right here, and that has a y value of -5. So I'm going to go all the way from when y is -5 until the highest point of my graph, which is right here, and that has a y value of 5. So all of these x values are going to produce, everything between -7 and 7 are going to produce y values that are between -5 and 5. So hopefully your confidence on these are getting better. Now moving on, so that's all we have to do for number 6. The last couple on this page have to do with graphing calculators. So for number 7, this one, you don't have to do this on the graphing calculator, but it makes it a whole lot easier. On the flip side, for number 8, you're going to have to use a graphing calculator for these to be most accurate. But if we're starting off on number 7, so if a rock falls from a height of 30 meters on Jupiter, the height in meters after x seconds is approximated by the given function. And we want to know, when does the rock strike the ground? So the first thing we're going to do is we're going to actually go to our graphing calculator and plug it in. So if I pull up my graphing calculator, you're going to open a new document and you're going to go to number 2 to add graph. So from here, now all I'm going to do is actually enter in my function. So in this case, it's 20 minus 6.2x squared, and that's right there. So 20 minus 6.2x squared, and you're going to hit enter, and it shows up. But in this case, I want to be able to see my whole graph. I can't see the whole top half of my graph. So I'm going to go to my menu and go to number 4. Whoops. My bad. Menu. So number 4, window zoom. And number 1, window settings. And this is kind of where everything we learned in transformations come in handy. Because if you notice, I have a plus 20 over here. So in this case, I know I'm going to go up 20. So my y max, I'm going to put it a little more than 20 just so I can see my whole graph. So I'm going to make it like 24. And y min, we don't really care about anything that's less than 0. So I'm going to put it at -1 so we can actually see 0. And from here, if you click OK, now you can actually see your whole graph. So now is the point where we actually want to put a point on this graph. So what you're going to do is I'm going to go to menu and go down to number 8, geometry, and then number 1, points and lines, and number 2, point on the graph. So what you're going to do is hover over it, remember, and click enter twice. And now I have a point on there. And I have to remember to click escape to get rid of this thing right here. And that, notice, goes away once you click escape. So I'm actually going to move my function out of the way real quick. So if we're looking at this, let's look back at our paper for a sec. So from here, it says when does the rock strike the ground? So if I have all the ordered pairs on my graph, the x coordinate is talking about time, and the y is talking about the height. So in this case, we want to know when does the rock strike the ground. So we don't know what time it does. That's our unknown in this part. But we know that when the rock strikes the ground, that's when the height is 0. So I want to know what the time is when the height is 0. So now if we go back to our graphing calculator, from this point, I know, remember, that we know our height is 0. We want to know what the time is. So if you type in 0 and hit enter, notice my point drops down here, and I'm left with 1.8. So from here, so I'm saying when x is 1.8, comma 0, that's the time it takes for it to actually reach the ground. So our answer on this one is just 1.8 seconds. 1.8 seconds. So that's the amount of time it takes for the rock to strike the ground. So that's all we need for number 7. Now number 8, it says the data, we want to be able to use a graphing calculator to find a linear function of best fit, or line of best fit. And so let's read number 8. The data listed in the table represents the monthly cost of producing X bicycles at a certain bicycle shop. Let the number of bicycles represent the independent variable, and let the total cost represent the dependent variable. So all it means when it talks about independent variable and dependent, we're just saying the total cost of production actually depends on the number of bicycles that you produce. That's why this, in this case, is the dependent variable, because this is what varies. So I'm actually going to go to my graphing calculator, and we want to enter all of this in. So if you go home, and we go to number 1, new document, and we don't need to save that. We want to go down to number 4, add lists and spreadsheet. So if you go to number 4, add lists and spreadsheet, I'm going to put all this information in there. So I'm going to call bicycles X, and I'm going to call my total cost of production, I'm going to just call that Y. And now I just want to actually enter in all of that information. So if I type in Z, I'm going to put all my information in. 60, 102, and then 150, 90, and 223. And then put in all my cost of production. This is 24,000, and then 27,750, 31,500, 35,250, 39,000, 42,750, and 46,500. So now I have all my data actually entered in into my calculator, and I want to actually put that in a spreadsheet. So if you go to Control Doc, that just opens a new window. And we want to go down to number 5, data and statistics. And all of my points pop up on there. And I just want to define my axes. So remember, we're talking about number of bicycles being the x-axis. And we're going to talk about total cost being our y-axis. So if you plug those in there, then all of your points shift on your graph. And I want to find the line of best fit through all of those points. To do that, all we go is we go to menu, and we go down to number 4, analyze. We go down to menu, analyze, and then go down to number 6, regression, and go to number 1, linear. So if you notice, then it pops up on our graph. So that is the equation or line of best fit through all the data. So for number A, or for letter A, excuse me, all we're going to do is type that in. So in this case, remember we have to do in function notation. So in function notation, we're going to say f of x equals, and then it was 9.95.861, because we're doing to 3 decimal places. So 95.861x plus 24,979.4. So that is the line of best fit through all of this data. Now we can actually use that to make predictions. So notice in B, it says using the line of best fit, estimate rounded to 3 decimal places the number of bicycles produced if 40,000 was spent on production. So in this case, right, when we're talking about our ordered pairs, the X value is going to represent the bicycles. And my Y, remember, is the total cost spent. So my ordered pair is going to look something like, we want to know the number of bicycles produced if 40 was spent. So we don't know the number of bicycles produced, but we know $40,000 was spent on it. So now that I know that, now I need to actually put my that line of best fit on a graph. So if you go back to your graphing calculator, what you are going to do is you are going to open a new window, which again is Control Doc, and we want to go to number 2, Add Graphs. And from here, now to get that line of best fit actually onto our graph, what you do is you hit var, and you go down to stat, that one, reach QN, I don't know. And all you do is hit enter. And then all we have to do is type an X into the parentheses. So notice the cursor actually pops up already between them. Just type in an X and then hit enter. And now the trick is actually finding our graph. So we know that it's there, and we want to actually find it. So the first thing I usually try is I go to Window Zoom, and I go down to a Zoom Fit. And in this case, it actually kind of works. And now I just want to modify this a little bit, because I don't care what's happening over here, because we're never going to have negative bicycles produced. So I'm actually going to go to my window and then number 1, window settings. And for X-min, that's what I'm talking about. So X, we don't care what's happening less than 0. So I'm going to put that as 0. And number of bicycles, I'm going to actually just put 300 in, because if you look at your table, notice over here, nothing goes past, in this case, we're looking at $40,000 spent. So I'm going to actually guesstimate that it's between 150 and 190, somewhere in there. So I'm never going to go past, I'm going to put 225 as my max, my X max. So if you click OK, it's a little off, notice. So I'm actually going to go back real quick and, oops, zoom, window settings. X-min is going to be 0. I don't know why it jumped like that. We're going to put that as 225. Okay, well, there's our line. So we know it's going to be somewhere in there. And I want to put a point on my line. So again, now I go to Menu, and I go to number 8, Geometry, number 1, Points and Lines, and then number 2, Point on our line. So if I put point on our line, and I hit enter, now all I have to do is hit escape, and that gets out of the adding points. Move that out of the way. And from here, remember, now from over here, we want to know the number of bicycles produced when we spend $40,000. So this part, I'm going to change to 40,000. And now I just have to find my point. So sometimes it says undefined. That just means it's out of your window. So if we go up, it should be somewhere on our graph. And I just have to find it. So if you scroll up, notice that is when the total cost of production, when we spend $40,000. And my Y value on that, notice, is 157. So basically what this means is when I produce 157, if I were to produce 157 bicycles, I would spend $40,000. So going back to my graph over here, I'm saying this is 150. When I produce 157, I can expect to spend 40,000. So the number of bicycles produced is actually going to be 157. And then remember, we need bicycles. So that's it for page 2. Stay tuned for page 3.